All right, this little video is for the group A's so that I can maybe try to help you a little bit more with this homework assignment that you've been working on virtually. So I just had class this morning with the B's, and I could definitely see that they were struggling with this homework. So they were in class with a teacher to help them. I can only imagine how much trouble you're having trying to do this from home. Now, in the last video, okay, in the last video that was linked to example 3, if you remember this example 3 that was linked, okay, I worked out homework problems numbers 2, 4, and 5. So if you need help on those, you need to go back to that last video. So what I was thinking I would do in this video is let's revisit number 1 just to make sure that that one is correct and you understand it. And then I'm going to work through numbers 3 and I'm going to work through number 6, okay? So between these two videos, we would have worked out and gotten extra help on numbers 1 through 6, and maybe this will make you feel a little bit more confident to then finish the assignment. All right, let's start back over with number 1 and see how you did. This problem is y cubed equals 5y squared. So our entry point is always going to be to write the equation in standard form. So I'm just going to simply subtract over 5y squared, set it equal to 0. Now my second thing I'm going to do is a GCF. And what I notice is that they both have 2 y's. So we're going to factor out a y squared. Well, the result is going to be y minus 5. When I look at this result right here, okay, since the y is not even raised to a power, this y minus 5 is completely factored. You're not going to be able to factor that part more. So what we're going to do is we're now going to set each factor equal to 0, okay, and we're going to solve. Now let's remember this part right here. Y squared equals 0 means that it's y times y equals 0. That means that the first y equals 0 and the second y equals 0. What did we call that in class when you have this repeating factor? Okay, it starts with an m. What that is that means that y equals 0 with a multiplicity of 2. That means that that y equals 0 counts twice. And then our other solution is going to come from adding 5 over, and we're going to get y equals 5. And so you can look on the answer scrambled and see if you can find y equals 0 with a multiplicity of 2, and then we get 5. Okay? So hopefully that helped kind of get you started on the right foot. Number 2 I worked out in the previous video. So I'm going to come back to number 3. I at first skipped over number 3 because it was similar to the example we did in class on Monday. However, like I said, my group B's were still having trouble with this, so I thought, you know, maybe it would be good to go over one of these factor by grouping problems. Step 1, write it in standard form, and it already is. Step 2, factor out a GCF. And what I notice is in this case, there is no GCF. And so what we're going to do is we are going to use factor by grouping. That's our only type of factoring we have when there are 4 terms. So the first thing I'm going to do is I'm going to group the first 2 terms in a parenthesis, okay? And then when we group the second 2 terms, remember, we always want to have a plus sign connecting our groups. So that means that the negative g and the negative 3 are going to go into the second group. And then we take out a GCF from each group. So the GCF in the first group is going to be g squared, and the result is going to be g plus 3. Now, what can we take out of this second group? Okay, well, it doesn't have as obvious of a common number. And really, g and 3 don't have a common number, so we're going to factor out a 1, except you see how both of the terms are negative. Well, instead of factoring out a positive 1, we're going to factor out a negative 1, which would then make the result negative g turns into positive g, and negative 3 turns into positive 3. And now when I look at my 2 groups, I have this group and this group, what do both of those groups have in common? And we can factor out a common g plus 3 with the 2 outside pieces, g squared minus 1, left over. Okay? Well, now is where we need to decide if we want to factor more. It is possible for you to right now, you could right now take your solutions, your 2 factors, and set them equal to 0, because we know how to solve for an x squared or a g squared. But you might also recognize that this is the difference of 2 squares. And so when I factor g squared minus 1, this is going to be that Squaresville factoring where you split the terms 50-50, okay? You split the g squared, you split the 1, and the signs are always going to go plus minus. So we should always try to factor more if we can, but if we can't, we can always take that quadratic and set it equal to 0. We have g plus 3 equals 0, g plus 1 equals 0, and g minus 1 equals 0. So we get g equals negative 3. We're going to minus the 1 over and get negative 1. And in this last factor, we're going to add 1. And so right there are the 3 solutions. Now I'm going to come back over here. Let's suppose that I did not factor the g squared minus 1. So I would still minus the 3 over and get negative 1. But what would happen here if we added over the 1 and use square roots to solve? Well, we would need to remember that you get plus or minus. That's probably the most important part if you're going to solve using square roots, is you have to remember the plus or minus. Well, the square root of 1 is just 1. So either way, whether you factored the g squared minus 1 more or you just set it equal to 0 and solve it, you're going to get negative 3, you're going to get negative 1, and you're going to get positive 1. Okay? So that just shows a little bit the flexibility that you can have when you're solving this, that sometimes there might be a couple different ways to go about it. All right, so I'm going to go back to number 6. Number 6 is another factor by grouping problem, but I will tell you this is going to be significantly more difficult than example 3. So I think this is a good one for us to go over together. All right, it's already set equal to 0, and I do not see a GCF for all 4 terms. So let's go ahead and start factoring this by grouping. Let's group the first 2 terms. And again, we want to always combine our 2 groups with a plus sign, which means our second group is negative 9x squared plus 36. And let's take out that GCF from each term. This time, the GCF is x to the 4th, which is going to leave us with x squared minus 4 left over. Now, what about from this group? Well, what I notice is that 9 goes into 36, so we can factor out a 9. But not just a 9, because that 9's negative, we're going to factor out a negative 9. And it's going to make this a positive x squared, and the 36 then, divided by negative 9, is going to result in a negative 4. So I still have my 2 groups. What do my 2 groups have in common? Okay, well, what they have in common is an x squared minus 4 with the 2 outside terms, x to the 4th minus 9, left over. Now we're still looking at getting 6 total solutions because of this degree, okay? So this one right here, I notice that it is the difference of 2 squares, okay? It's an even exponent, and we've got perfect squares. So this can split more, and again, we split those terms 50-50. I can split the term into 2 and 2, and it goes plus minus. This x to the 4th has to be factored more. You don't even know how to like 4th root both sides, and we don't even know how to solve an x to the 4th. Well, we do know how to solve an x to the 4th, and we solve it by factoring. So I split the x to the 4th into x squared and x squared. I split the 9 into 3 and 3, and the signs always go plus minus. Okay? Well, now when I look at this, x plus 2 is factored, x minus 2 is factored, x squared plus 3 is factored, and x squared minus 3 is factored. See, these 3's are not perfect squares, so I can't factor this anymore. No big deal. We set each factor equal to 0. I set x squared plus 3 equals 0, and we set x squared minus 3 equals 0. See, it's not a big deal that these x squareds don't factor more, because we know how to solve a quadratic equation. Okay, that's why we had the unit prior to this one. I'm going to minus the 2 over, and we will get x equals negative 2. I'm going to add over the 2, and we get x equals 2. Now this one's going to be a little bit more work. I'm going to minus the 3 over, okay? And now we get x squared equals negative 3, and I need to square root both sides to solve for x. So we get x equals, always put plus or minus after square rooting both sides. All right, because we're square rooting the negative, that's going to be represented as an imaginary number. And we'll then have the square root of 3, which can't be simplified, okay? So that's what that those two solutions are going to be, plus or minus I square root of 3. Now over here, we're going to add 3 to both sides. And again, let me fix that out spacing-wise. Okay? And then again, we're going to add 3, and we get x squared equals 3. So I square root both sides again, but this time I'm square rooting, so I put plus or minus, but I'm square rooting a positive 3, so it's going to make a real solution, plus or minus square root of 3. So what are all of these 6 solutions? One of them is -2, one of them is +2. We got that from the first 2 factors. One of them is negative I square root of 3, the other is positive I square root of 3. We got that from right here, okay? Then we have from our last factor, we're going to have x equals a negative square root of 3 and a positive square root of 3. And that is all 6 solutions. Okay? Now, I don't necessarily mind. And what I did in the answer scrambled is I wrote out all of the solutions separately because I want you to understand that when we say plus or minus, it's not a multiplicity. It actually means that there's a negative and a positive. Now, I am totally fine if you want to write your answers as plus or minus 2, plus or minus I square root of 3, and plus or minus square root of 3. That is okay too. You just need to know what that plus or minus means. Okay? I hope this helps. It's the best I can do for trying to help you virtually. Let's see, and there's a lot of repeating problems. Okay? And so see how you do on 7 and 8, 9 and 10. Take it from there, and I hope you have some success with this. All right? Good luck. Reach out to me. If not, I'll be available through email, or you can always text me through Remind, but I'm here to help you. See you tomorrow. Bye.